So welcome back. Finally, we're going to start doing questions involving the geometry of parallelograms and triangles, and this specific one is going to be about area because that's kind of the most common one they're going to ask, in my opinion. So the questions like this: we have a shape here, and the shape is made up of three parallelograms. So ABCF, ABFE, and ACED. So the first one, ABFE, is this corner here, this corner here, this corner here, and this corner here. So it's going to look like this one here that I'm drawing in red. Okay, so ABCF. Alright, so that's one of the parallelograms. The next one we're going to look at is ABFE. So that's this one here. ABFE is going to be from, so again, it's AB, this point F, and this point E. So it's going to look like this, A, B, F, and E. Okay, see that blue one there I'm drawing? And then finally we have A, C, E, and D. So I'm going to do that in white here. So A is this corner here, C, D, and E. So this is the big parallelogram. It's going to be like this. Okay, and hopefully you guys can see that. So it's three parallelograms kind of crossing over that make up this entire shape altogether. And then lastly, the triangle AFE, which I will do in, I'll go green, I guess. Triangle AFE is equal to 20 centimeter cubed. So that's this triangle here. So we have the point A, we have the point F, we have the point E. So it's this triangle here in the green. I just need to shade this in a lot, make it clear. This triangle I'm drawing out there. So the shaded in region is 20 centimeters squared. Okay, so I'm going to just get rid of all these drawings. Back to our original. Almost there. There we go. Okay, so now we're back to our original drawing. The question is, what is the area of the entire thing? So how are we going to get this? How are we going to even approach the question? So we're going to do this bit by bit. I'm even going to write that down. I probably say that a lot, but that's just the best way of attacking most of these geometry problems, is just getting loads of different angles and areas and lengths, and eventually the whole question will kind of come together. But if you don't know where to go first, just start something, and then eventually the answer hopefully will become clear if you keep doing things that are correct. So we'll go bit by bit. The first one I'm going to do is I'm going to look at this triangle here, or this parallelogram ABFE. So I'm going to look at ABFE, and this is a fancy trick, or not a fancy trick, sorry, a handy trick, and to say that you can use for geometry and for trigonometry. So again, this is just a rough sketch, A, B, F, and E. Just by drawing each shape out individually, it'll really help. Okay, so I'm going to draw this yellow line, AF, okay, which is going to be like that. And again, in this one it's flat, but just a bad drawing, like I said. And then the triangle AFE, I'm going to shade in here. Okay, so now we have the triangle AFE. Ooh, AFE. Oh god, I'm making a mess of this. Sorry. The triangle AFE is equal to 20 centimeters squared. Okay. And we also know that a triangle made up of a parallelogram, so if you have a diagonal that cuts a parallelogram in half, it makes two congruent triangles. So this triangle here, the blue, is the same as this triangle here, number 2. Alright? So that means the triangle AFB also has an area of 20 centimeters squared. Because these are congruent, this has to have the same area. So I'm going to say congruent to the triangle AFE. Okay, so that's my reasoning for it. So now I'm going to color in that ABF. I'm going to color it in blue. Okay, so like I've just drawn in there, I've colored it in blue. AFB also has an area of 20 centimeters squared. I'm just going to put a box around that. So it's our first piece. I guess I'll put a box around this. AFE is equal to 20 centimeters squared as well. So now we're going to do the exact same thing for this parallelogram AFBC. Alright? And then this will be pretty handy to find out what the next bit of the question is. So I'm going to say AFBC, and then that parallelogram is going to look like this. Okay, and then we have this yellow line here that goes from here to here, and then again our blue shading, which I'll just quickly do here. So now we have the triangle, so I'm going to draw the points in A, B, F, and C. Okay, I'm going to scroll down, just I want it to be able to see this at the top here. So scroll down. We know that the area of the triangle, so AFB is equal to 20 centimeters squared. And we also know then, so it's the same reasoning, that the triangle, so I'm going to say the triangle BCF also is 20 centimeters squared. Okay, and the reason I'm going to say is because, again, this is a diagonal through a parallelogram, so these two triangles, this one here and this one here, are going to be congruent. Okay, so I'm going to say congruent to the triangle AFB. So now we have our second piece of info here, and I'm going to go up and I'm going to color that in red. Okay, so now we have these three bits here. Each of these are 20 centimeters squared, all the shaded bits, so AEF, ABF, and then BFC. So this is 60 centimeters squared, and now we need to find out what this shaded region here, ECD, is. Okay, so how are we going to do that? We're going to do the exact same thing that we've done so far. So I've just taken a quick screenshot of this, and I'm going to bring it down and copy it here. See how it works. Okay, perfect. So now we have all the information we have so far. So I'm going to look at this triangle AFBC, or sorry, the parallelogram AFBC quickly. So we're going to look at this parallelogram, which I'm just going to sketch out AFBC. Okay, so we know that this is made up of two separate parts. We know it's made up of the blue shaded part and the red shaded part, and that altogether the area is 40 centimeters squared. Okay, because this is 20 and this is 20, so if you add those together, you're going to get 40 centimeters squared. So now, if we look at this line here, AC, so it is kind of hidden away behind the red and the blue. But if we draw this line in here, AC, okay, so now again we've split this parallelogram into two separate triangles, and each of those triangles is going to have half of the area in. So that means this triangle here, so the triangle AFC, is equal to 20 centimeters squared. Yeah? Because it splits the area in two, because it creates two congruent triangles. So now what we have is, I'm going to go down a little bit. I'm going to draw this ACED, so this parallelogram here, and we're almost done now. So A, E, D, and C here. So we have A, E, C, and D. And what I'm going to do is, oh no, this line here, never mind. Like this here, okay? So now I'm going to clearly draw on this purple shaded region into this drawing here. Okay, so quickly shaded in AFC there, the purple triangle. So now hopefully you see where I'm going with this. So we have the triangle ACED here, or the parallelogram ACED, and this entire half of the parallelogram, so ACE, this big triangle, is made up of two separate little triangles, and each of those triangles has an area of 20 centimeters squared. So the purple bit is 20 centimeters squared, and the orange bit from the very start is also 20 centimeters squared, as it says here. So that means that this entire area here, which I'm now going to shade in white, is 40 centimeters squared. And what do we know about diagonals across parallelograms is that it makes congruent triangles. So that means if I draw this green part in here, green squiggly part, that is also 40 centimeters squared. So I'm going to say the triangle ECD is equal to 40 centimeters squared, and I'm going to say congruent to, and again it's going to be the triangle AEC. AEC. Okay, so now we have every single individual part of our triangle, so I'm just quickly going to fill this in green. Okay, so sorry for this kind of long video. So now we have an orange part, a blue part, a red part, and a green part, and we have the area of each of those individual parts. So this is 20 centimeters squared, 40 centimeters squared. Again, this is also 20, and this is also 20. So I'm just going to say that the area of the entire thing is going to be 20 plus 20 plus 20 plus 40, which is going to be equal to 100 centimeters squared. So that's the end of this question. So hopefully that kind of showed where all the rules we learned in the last few videos are useful. So things like two congruent triangles out of a parallelogram, yeah, that's kind of the main rule we use there, and just about having to attack the problem bit by bit and then eventually coming to the answer. So there's no way to do this quickly. You have to go through every single step to find the entire area. So I'm going to leave it there. I don't want it to go on for too much longer. That's going to be the last of the questions. I'm not going to go through loads and loads and loads of questions in these videos because it wouldn't really make any sense. It's up to you guys to do the questions and just practice them. It just makes more sense that way because each question can be so different that there's no one thing to learn. Once you know all the rules, it's just about practicing and practicing and practicing. So in the next video, we're going to start looking at ratio, so how you can solve problems using the ratio and parallel lines and stuff like that. So you'll see what I mean if you watch the next video. Hope you enjoyed this one. If you have any questions, ask them down in the comments, and we'll see you in the next video. Don't forget to like and subscribe and share them with your friends. So we'll see you next time. Thanks for watching.